we're going to introduce a concept today that you already understand, I think, I hope. It's called a sampling distribution. So we're talking about sampling distributions for much of this chapter. One of the things that's introduced finally in Chapter 7 is something that we've been talking about for a while, and that's a statistic versus a parameter. I think I told you that when I took stats, I totally didn't catch the difference between a statistic and a parameter, and I don't want that to be the case for you guys, because my first year of teaching it, I'm like, oh gosh, here comes that statistic and parameter thing. I hope I can get this worked out. And when I looked at it, I went, really? That's all it is? Shoot, I got that. So, do you guys remember what the difference is between a statistic and a parameter? What's a statistic? Yeah. Right, exactly. It's something that's calculated from a sample, right? Or it's a sample calculation. There are many sample calculations. Some of the common ones are X bar, right? The sample mean. Standard deviation of the sample, SX or just S. The sample size, those are all statistics. That's gathered or calculated from the sample, or counted in the case of the sample size. So you're right, statistics are related to the sample, and so the parameter is the population. Now, population calculations doesn't really make sense. Population values is probably better said, because oftentimes you can't know what those values are. So mu, which corresponds, it's the population version of X bar. Sigma, it's the population version of SX. And big N, right, for our population size. Again, we've talked about this a number of times. Oftentimes these are unknowable. They have to be given to us, and how they've been assessed is really what sampling distribution is kind of about. The other thing is sampling variability that we need to talk about first. Now, if I took all the students at Centennial High as my population, and I took a sample of, say, 20 of them, and I went to those 20 randomly, and I said, what's your favorite color, right? Or what's your age, or something like that. And I got some data from those 20 people. And let's take the color, for example, and I figure out what is the favorite color of that 20. And then I could say, maybe I could say, hey, I think the Centennial's favorite color is this, right? Perhaps I could do that. But let's say instead of doing that, I get that group's favorite color, and then I go to another random sample of 20, and I go, hey, what's your favorite color, right? And I get that group's favorite color. And I keep doing that. Am I going to get the same exact answer from each group of 20, do you think? No, no. They might all kind of roughly group into one area, but sampling variability refers to the fact that different samples of the same size from the same population will give different results for the statistic. refers to the fact that different samples of the same size from the same population will give different results for the statistic. Two real key things in here are same size and same population there. Those are important. All right. So everybody's good with sampling variability, right? That makes sense. Yeah? Okay. Now, we get to talk about the biggie, sampling distribution. So, for a long time, this was just a word to me that kind of would just slip by as I was reading a problem or something like that. And I didn't maybe fully appreciate what its meaning was. And then when I did figure it out, it was kind of one of those light bulb moments like, oh, I get it now. Sampling distribution is the distribution of values taken by a statistic in all possible samples of the same size from the same population. Okay, before we write that, let's say I take this class. What do we have? We've got about 30 people in here today. And I take 3 of you and I say, how old are you? How many months and how many years, right? And I take those 3 and I average that value. And then I take another group of 3 and another group of 3 and another group of 3 and another group of 3. And I keep asking the same thing. How old are you? And I average those values for each group of 3 in here. Each possible group of 3. So what that would mean is your age would get averaged with everybody else's at one point and every combination of 2 other people that's possible to put together in here. And I take all of those averages and I average those. What would I get? The average, yeah. It would actually be, oh, Kara, did you have?
Just be the average.
It would. It would be if I took everybody and just said all 30 of you and said, hey, what's your age? And then took all of those, I would get the same value. So if what the sampling distribution refers to is the taking of all possible samples of a certain size from a certain population and taking those averages and then averaging all those averages, what you will get is a parameter. You'll get the population value. So, let's write it first. Is the distribution of values, and when we say distribution, we need to be thinking shape. Of values taken by a statistic In my example, I used mean as a statistic, an average of age, in all possible samples of the same size from the same population. We actually did a sampling distribution on day one. Do you guys remember the activity we did on day one with the airline pilots that were chosen, the females versus the males? And we had all the black beads and the white beads and all that. There were more males than females, but more females were chosen. And we tried to find out if we thought that that was realistic, that I think it was 5 females and 3 males out of this group were chosen. And we charted all of our samples. Everybody had a sample. So the sampling distribution was the chart of all the samples, right? So that's what a sampling distribution is. It's looking at a lot of data, but it's looking at data of data, sort of, and it leads us to the idea of getting to the parameter. So we did this in the pilot problem. Right? And that pilot problem and that graph, we summarized the whole class almost. In some ways, in many ways, we summarized that whole class on day one, this whole class. It's really a pretty neat problem. Okay.